One of the problems you'll run into when you need to export data out of a Power App is that most of the time the go-to solution is to hand the whole thing off to Power Automate. You build a flow, you connect it to your app, and you let the flow generate the CSV and send it via email. That works in a lot of cases, but it comes with a lot of overhead for something that should be very simple. In this video, we're going to get rid of that flow entirely and build the export directly inside the app. We'll create one reusable function that can take literally any table, a collection, a SharePoint list, or a Dataverse table, and turn it into a properly formatted CSV file, all within PowerFX, with no flow in between. This entire export is going to come down to a single manageable formula by the end of this video. So let's get right into it. Channel members have access to download the apps used in the videos, as well as the YAML code used in the components that I showcase. You can click the join button below the video if you're interested in supporting the channel. To start off, we'll go ahead and add a small sample table so we've got something to test against as we go on. In our app formulas, we'll go ahead and add a named formula called fx example data with a few rows of dummy data in it. Just one quick mention on naming conventions before we dive in, since we're going to be creating quite a few functions and variables in this video. We'll use the fn prefix for user-defined functions, fx for named formulas, tp for user-defined types, and the standard var for global variable, and scp for scope variables inside a with function. I like to keep these consistent across all of my apps because it makes reading these formulas a lot easier later on. The technique we're using today really just comes down to building a big block of text in CSV format. So the rows of values separated by commas with a line break between each row. With that in mind, there are a couple things that can show up in your data that will break that formatting the moment they appear. So before we build anything else, we also need a way to escape those or capture those. The most common one is a comma inside of a value. So if we build a CSV string by hand and one of our values happens to have a comma in it, say a name like Smith, John, and we open that inside of Excel, we can see the comma splits that value into two separate columns. That's obviously not what we want in this case, and the same thing happens if a value has a line break or a quote character in it. So we'll go ahead and create our first function to handle this, and we'll call this fn CSV cell. All this function does is wrap a value in quotes, and if there's already a quote inside the value, then it doubles it up. That's how the CSV formatting escapes a literal quote character. So if we run the same messy value through fn CSV cell, we can see it comes back as one safe quoted cell, no matter what's inside it. We'll use this on every value inside of our export from here on out. Now here's the part that used to be genuinely difficult to do inside of Power Apps, and that's reading a table's column names without knowing them ahead of time. We can actually do this with three functions working together: JSON, parse JSON, and column names. So we'll go ahead and take our table and run it through JSON first, which then turns our table into plain text. Then we'll run that text back through parse JSON, which gives us something that PowerFX in this case can inspect. Then this last part is that we can call column names on the first row of that data, and it hands us back the column names directly without any schema or hard-coded information. So let's go ahead and build that into a real function called fn CSV from JSON. There's a lot going on in this formula, so we'll walk through it piece by piece. The first part is the name and the input parameters here. So this formula takes in one parameter called JSON, and that's the JSON text that will be generated when we call this function. That returns a text value to whatever calls this function, which is going to be our finished CSV data. We'll go ahead and wrap everything in a with function, and the first thing we want to do is parse that JSON back into something that PowerFX can work with. So we'll store that in a scope variable called scp data. Right inside that, we'll nest a second with function, and this is where we can actually get the column names from our data. We'll grab the first row of scp data using the first function and run it through column names, which then hands us back every column name in that row. That list will then be stored in SCP columns. Now we'll go ahead and build our header row. Using the concat function, we'll loop through the SCP columns, calling each of those as SCP column as we go. We'll run that name through fn CSV cell so that it's properly escaped, and then we'll concatenate all of those together with a comma in between. So that gives us one line of our header text. At the end of this, we want a line break between our header and our data, so we'll just concatenate character 10, which is the standard line break character in a CSV. Next, we need to loop through every row in SCP data, calling each one SCP row. For each row, we'll loop through our column names again, and for every column, we'll use the column function to pull that specific row out by name, convert it to a text value, and then run it through fn CSV cell to escape it. Concat joins those into one line, and we'll store that line in a field called CSV line. So by the time this for all is finished, we've got one CSV line built for every row in our table. The last piece then is that we'll take all of those CSV line values and run them through one more concat, joining them together with a line break in between. When we put our header, that line break, and this body all together, then that combines everything into our finished CSV. Let's go ahead and test that against our sample data now by typing it into the formula bar. In this case, we always need to use the JSON function on our data before we pass it into our formula, as our formula is only expecting a text value here. But we can see with that one line, we've got a full CSV format, a header row, as well as our rows of data. Before we go any further into improving this and making it smarter, let's go ahead and improve the actual point of this video, which is to deliver the report by email. We'll insert a button into our screen and we'll set the onSelect property to build that CSV and email it straight to the user. One of the most important tricks here is how we actually attach the file. So the Office 365 Outlook connector has the Send Email v2 action, and that takes an attachments parameter. Now, this attachment needs to be structured a very specific way for Power Apps to accept it. So we need a name column for the actual file name, a content bytes column for the actual file data, and an OData type column that tells the connector what kind of attachment this is. So name is just what we want to actually name the file once it lands in the inbox. Content bytes is where our CSV text data goes, and Power Apps handles the encoding of that for us, so we can just hand it our plain text. The OData type is not really terribly important in this case. It just cares whether that column exists in the attachment object. Some sources online do say it needs this Microsoft.graph.file attachment text in there, but you might find that it works perfectly fine without that, and you can just pass it an empty string. So with that set up, we now can just click our button and a real CSV gets attached to a real email and sends it directly to our inbox using this Office 365 Outlook connector. There's no flow behind this, and there's nothing to publish and fix and reconnect if things change. So if we go over to our email, we can see this email got delivered to us. We can open our file and we can see our example data. Now that works great on our sample data, but let's see what happens when we point this to a real SharePoint list instead. And in this case, one with a choice column on it. The first warning we get is that this data source uses media, which we can't convert to JSON natively. And we wouldn't want that for a CSV export anyway. So we'll enter a comma after our data source and enter JSON format.ignore binary data and JSON format.ignore unsupported types. And that way we're just grabbing whatever we can pass to JSON to pass into our CSV. You can see when we point this to our SharePoint list, we get an error saying that the untyped object argument to the text function has an incorrect type. If you've worked with SharePoint choice fields before, you probably have run into some version of this. And the reason this doesn't work is because choice columns are actually a record or an object. These come through with a value property that has the text of the choice field inside of it. A person field does something very similar with the display name and other aspects of that person. Our function tried to convert an object straight to text, and PowerFX isn't going to let that happen. The way we'll handle this is by creating a new function called fn_cell_text. And in this function, its whole job is just to take one raw value and figure out what that shape of data actually is. So our input parameter will be called source value, and this will be a dynamic value because it's coming from an untyped object. The value we want to return in this case is text. In this function, we'll use the coalesce function to essentially check different types of data that could possibly mess up our CSV export. So we'll use the if_error function followed by the text function, followed by our column function on our source value. And for each of these, we'll see if different columns are existing in this text. So a value column for that choice value from SharePoint, maybe a display name from a person or group. And once it checks those different data types, then we'll concatenate all of those together to get the non-blank value. Now in our CSV function, in place of the plain text call, we can place our new formula for fn_cell_text. Let's run this again against the same SharePoint list, and we'll head over to Outlook to see what we actually get in our inbox. We can see that this works now. So our choice field came through. It's coming through as clean text. And we also have all of our person type fields like author and editor. Now, if we look closer at the header row in this last export, we'll notice that the columns came out in an order that we didn't specify. That's just a side effect of how the JSON function serializes a record, and most of the time we're going to want control over that. So next we'll build a version that lets us set our own column orders as well as which columns to include. In our app formulas, we'll go ahead and create a user-defined type called tp::list, which just describes a table with a single column of text in it. After this, we'll create a new function, fn_csv from JSON ordered, that takes our JSON just as before, but also takes a list of columns using that type. So we'll make a copy of our previous function, give it our new name, and then we'll add an input parameter of columns with the type tp::list. We can remove our second with function in our formula since we no longer need to get the column names from our JSON input, and then we can start to replace our references to SCP columns with our columns parameter. So we'll do that in the first concat, and then also within our for_all for each row of data. By doing this, we're providing the column names to our formula, and then using that to build our header row as well as each row of individual data. So we feed that to our column function inside of the for_all function to provide the name of the column that our function should go and find the value for. So now we can go back to our button and we can go ahead and call this new function with a list of input column names like author and field_1. We'll change the formula that we're referencing, and then inside of brackets, we'll put each of the columns that we want to list inside of quotes. One thing that's worth calling out here is that the names we're passing into that list need to match the actual internal names of the columns, either in SharePoint or in Dataverse, since that's what's coming through in our JSON function. They're not necessarily the friendly names that we see on the list or in the table. Author in this case is the created by field from SharePoint, and then field_1 is what we have as case description inside of our SharePoint list. If we want our CSV to come out with friendly names instead, we'll go ahead and run our data source through the rename columns function before we serialize it with the JSON function. Here we can rename each of those internal names to a friendly name that we actually want to see. Then in our column list, we'll list those friendly names that we just renamed those columns to, since those are the names that are actually going to show up in the JSON now. Once we do this, we can go ahead and click our button again, and we'll go to our export where we can now see that the author and field_1 are renamed to created by and case description. Now, because we've built this in such a flexible way, we can pretty much apply this to any data source of our choosing. So I could add a Dataverse table to our app, and we'll just add maybe the contacts table here. And we can go back to our original FN CSV from JSON and just plug in our new data source into this formula. Without any other changes, we can press our button and it will email an export of this table for us. All of the data that existed in that table got pulled into our Excel file. And again, you could take this a step further if you only wanted specific columns, and you could use rename columns to make these names the friendly names. But with this technique, it really is flexible to whatever data source you need. One last thing to note is that we can point this function to a gallery's items to export all of the filtered rows that are visible inside of a gallery. So if we insert a new screen and we put a gallery onto the screen, we can copy over our all columns button with our original JSON function, and we can just point this to our gallery's all items property. If we go ahead and click this button now, we'll see that we get an email with the sample items from our gallery. And only the columns that were actually used inside of the gallery got exported. So if we go back to our app and we point this to an actual data source, like our contacts list that we were using before, we can press that button again, and the export that we get this time is going to be a little bit different. In this case, I think it's explicit column selection that is kind of choosing which columns are actually used inside of the gallery, and those are what show up in the all items property. So you can see only a subset of those contacts columns are actually in use. We can add a function like first_n to filter to the first 3 records inside of that contacts list. And just as we would expect, the export now only includes those first 3 records. So you can use this in combination with a gallery in order to export certain records that are filtered to the user's view. And that's about it. We've built one reusable function that can export any table to CSV, and we've expanded that into a second function that we can use to choose specific columns. We can handle SharePoint choice and person fields automatically, and we have control over the column order when we need it. We did all of this without a single Power Automate flow, so there's no extra connection to maintain, there's no flow to republish, and one less thing in our app that can break without us knowing. If you liked this video, give it a like, and if you're interested in future videos like this one, be sure to get subscribed to the channel. Let me know in the comments what other tasks you've been handing off to Power Automate that you'd rather bring back directly into the app. As always, I hope you enjoyed the video, and have a great day.